Good morning, students. Today we are going to start with the chemical thermodynamics. Now, before starting the complete unit, let's look what is the meaning of thermodynamics. Our complete universe it is divided into the two parts, that is a system and surrounding. Now, according to that, what is system? System is something which is under the observation, and surrounding is anything that is other than the system. Means that surrounding is something which we are not observing. Now, these two parts, that is the system and the boundary, they are separated by a real or imaginary line which we called as a boundaries. On the basis of all this further, we see we have the two types of the basic systems, that is your homogeneous and heterogeneous. Homogeneous system is a system in which it remains in a single phase. There is the presence of only one phase. Whereas heterogeneous is a system where there is a different phases we can able to see. Further moving ahead, we have the different type of the processes. Different type of processes may first process we can say we have the isothermal. Isothermal, thermal stands for the temperature. In this particular process, our temperature is going to be constant. Next process is a adiabatic process. Adiabatic process, in this heat change is constant. Then third one is your isocoric process. In this your pressure is going to be constant. Fourth, sorry, isocoric may we have volume constant, and isobaric we have pressure equal to constant. Then we have the cyclic process. Cyclic process means what? We have the component that A is responsible to form a B, B is going to form a C, and then C again gets converted into the C. That is a cyclic process. Reversible process, another type of the sixth process is the reversible process. For example, we have a one component A. If you are going to heat it, it get forms B. But when you are going to cool the B, it gives you again the A. Such type of the processes are going to called as a reversible processes. And then last one is a irreversible. Means if once your compound is being formed, you cannot change it into the another form. Further, we have different we have done the types of system, a homogeneous and heterogeneous. Then we can also study according to the movement of matter and energy. They can be divided as the open system and the closed system. Open system stands for the system where there is an exchange of energy and matter between the system and surrounding is going to take place. Means your energy, your matter, they both are going to exchange between the system and surrounding. For example, in a beaker, if you are going to take a zinc metal and sulfuric acid, it gives you a ZnSO4 and hydrogen gas is going to liberate. Now, when this particular reaction is going to take place, there is a liberation of heat. So that is going to evolve. Plus, your hydrogen is also going to evolve. So they both are going to exchange between the system and surrounding, because जो भी hydrogen is going to release, it is going to go into the surrounding only. Next is the closed system. In the case of the closed system, no exchange of the matter takes place, but only the exchange of the energy takes place. For example, your cup of tea. Your cup of tea becomes cool after after some time. It means what? A heat exchange has taken place. So this was the brief introduction for our thermodynamics. Now further moving ahead, we can have the two types of the properties in which we read macroscopic properties. Macroscopic properties are the properties which arise due to the bulk of a system. They can be further divided into the extensive and intensive. Extensive properties are the properties which depend on the amount and size of the substance. For example, your mass, volume, surface area, internal energy, etc. And intensive properties are the properties which do not depend on the amount of the substance. For example, your temperature, viscosity, surface tension, these refractive index, these are what? They are the intensive properties. Now, the next thing which we have in the thermodynamics is the state of the system. Now, when we talk about the state of the system, we have the various properties, for example, the pressure, volume, temperature, and as well as their compositions. So, all these things which bring the change in the system, they are called as the state function, or you can say state variables. Means these are what? These are the factors which are going to bring the change in the state of the system. Now, when we talk about the state of the thermodynamic system, we can describe it by a measurable properties. Measurable properties कौन सी हो गई? जो macroscopic properties हैं. So, state अगर मैं गैस की बात करूं तो there will be the involvement of a pressure, volume, temperature, amount means the number of moles. So we can say कि gas के case में we have the different state variables like pressure, volume, temperature. क्यों? Because in values के ऊपर it is going to depend only that what will be the state of a system and how it is going to reach over here. That is your state of a system. In this, 1 marks question can be asked that define the state variable. So again, I'm repeating, state variable is what? It's state variable which brings about the change in the state of the system. Then next we have the internal energy. This internal energy we are going to read as a state function. It is denoted by the U. Now, what is this internal energy? Internal energy is what it is sum of or sum total of all the energies of the system. That is going to be called as a internal energy. Now, say suppose we have one component A getting converted to the component B. So for its internal energy respectively, it will be denoted by UA, it will be UB. Now if I want to take out the delta U, what is the delta U? It is the change in energy. It is going to be equal to UB means internal energy of B minus internal energy of A. Say suppose again I take two components. So in continuation, again we have the two components. Let's suppose volume for the component R is VR and for else it is VP. Now if I want to take out the change in the volume, what it will be? VP minus VR. Now in this case, always remember that if your internal energy, like over here, if I consider the internal energy, if my internal energy of the product is greater than of the reactant, then my delta U is going to be positive. That is your internal energy. If your value of the product is going to be lesser than the reactant, then your internal energy is going to be negative. This we have in the case of the internal energy. Another one more thing, internal energy ko we can also called as the your intrinsic energy. Okay. Now, what does this negative and the positive value means? I have told you that if the internal energy of product is less than the internal energy of the reactant, then the delta U is going to be negative over there. Whereas on the other hand, internal energy of product is more than the internal energy of the reactant, then your internal energy would be positive. So this internal energy is going to called as a state function, means that your this delta U, this change, it depends upon the initial, your reactant is going to be initial and the final states, and it is independent of the path. हमें इस चीज से कोई फर्क नहीं पड़ता that how this reactant is converted into a product. We are bothered about that your reactant, your what was your final product and what was your initial product. Now the next topic we have modes of transference of energy between system and surrounding. Now, every system is going to have a definite amount of energy. It can exchange energy with the surrounding in different ways, out of which the two important ways are what? Heat passes into or out of system. Another, work is done on or by the system. These are the two important modes of transference of energy between the system and the surrounding. Means कौन से हो गए? एक heat हो गया और एक work हो गया. So first of all we are going to study about the heat. Heat is what? It is denoted by small q. Then it is what? It is the energy is going to exchange, energy exchanged between the system and surrounding as heat if they are at different temperatures. Then we say that the exchange is going to take place or which has been taken place, it is the with respect to the heat. Now for example, just listen it carefully. For example, हमारे पास system है which is at a higher temperature than the surrounding. तो एनर्जी क्या होगी? एनर्जी इज गोइंग टू लॉस टू द सराउंडिंग। अगर सिस्टम गर्म है, फॉर एग्जाम्पल अ कप ऑफ टी इज गोइंग टू बी हॉट, तो उसमें से जो हीट है वो ट्रांसफर कहाँ होगी? हीट में। इट मीन्स इट हैज लॉस टू द सराउंडिंग। लॉस टू द सराउंडिंग का मतलब क्या हुआ? कि अल्टीमेटली सिस्टम का जो टेम्परेचर है इट इज गोइंग टू फॉल डाउन, दैट इज गोइंग टू फॉल डाउन। और जो सराउंडिंग हो गई उसका टेम्परेचर इज गोइंग टू राइज। सो दिस प्रोसेस कंटिन्यूज टिल, कब तक कंटिन्यू रहेगा? जब तक जो टेम्परेचर सिस्टम का और सराउंडिंग का है इट बिकम्स इक्वल। ऑन द अदर हैंड, वाइस वर्सा केस, अगर टेम्परेचर ऑफ अ सिस्टम इज लोअर देन दैट ऑफ सराउंडिंग, तो एनर्जी इज गोइंग टू गेन बाय द सिस्टम। Means there will be the flow of heat from system to the surrounding. If system has higher temperature, there is the flow of heat from surrounding to the system. So in both the cases what is happening कि exchange of energy is taking place, जिसकी वजह से temperature difference is coming. That temperature difference we called it is a heat denoted by the Q. Now the system, whether it is absorbing, or you say, we can say that we can have the two temperature TB and TA। एक को हम ले लेते हैं सिस्टम टेम्परेचर ऑफ द सराउंडिंग, एक को ले लेते हैं टेम्परेचर ऑफ द सिस्टम। Now in this case your internal energy will be what? Delta U is going to be equal to the Q. Now no work is being done over here and at a constant volume. So what is going to happen? Q is going to have the positive value when heat is transferred from surrounding to the system. On the other hand, Q is going to have the negative value when heat is transferred from system to the surrounding. This point we have to remember. Coming to the next part, that is your second one, that is the work. Now work is what? It is the another mode of the transference of energy. अब कभी भी हम कब कहेंगे that work is being done? We say that work is being done if the point of application of force is displaced in the direction of the force. Means it is going to be, we can say कि equal to the force multiplied by the distance। आप तभी कहेंगे कि आपने फोर्स अप्लाई किया, फोर्स अप्लाई करने पे जो भी आपका ऑब्जेक्ट था उसके अंदर डिस्प्लेसमेंट हैज गेम, और यू कैन से कि उसके पोजीशन के अंदर चेंज हो गया। Now in this we can have the two main types of the work which we study in this, that is your electrical work and we can have the mechanical work। इलेक्ट्रिकल वर्क जो है इट इज इम्पोर्टेंट इन द सिस्टम। क्यों? क्योंकि रिएक्शन इज गोइंग टू टेक प्लेस बिटवीन द आयंस। वेयर एज अगर हम मैकेनिकल वर्क की बात करें तो मैकेनिकल वर्क इज परफॉर्म्ड व्हेन सिस्टम चेंजेस इट्स वॉल्यूम इन द प्रेजेंस ऑफ द एक्सटर्नल प्रेशर। मीन्स मैकेनिकल वर्क उस केस में इम्पॉर्टेंट है जहाँ पे सिस्टम में गैसेस हैं। And this mechanical work is also called as a pressure volume work. It is also called as a pressure volume work. Now, this pressure volume work, uh, or you can say work, we understand by the simple example. से सपोज आपका सिस्टम है, उसके अंदर सिस्टम के अंदर कुछ वाटर है। फॉर एग्जांपल आपने एक इंसुलेटेड बॉटल ली और यू कैन से थर्मोफ्लास्क, देयर यू हैव केप्ट अ वाटर। नाउ